Good day everyone and welcome to this NPTEL online certification course on biological process design for wastewater treatment. So, today actually we are going to start with understanding how to characterize a wastewater. So, if we have to treat any water, we should understand that what are the various constituents which are present inside the water which are undesirable. So, during the biological or physico-chemical treatment of wastewater, we need to remove all these undesirable characteristics of wastewater and undesirable constituents present in the wastewater to a limit, so that we can use it for the designated purpose whatever we want to use the wastewater later on. So, we are going to study the wastewater characterization in detail in today's lecture. Now, the water quality determination or the wastewater characterization, this is very essential for various aspects. First and foremost, assessing the water quality is essential for devising the water quality management program. It also helps in giving us ideas that what are the probable use of the water that we are getting, whether we can use it for drinking, whether we can use it for bathing, whether we can use it for cleaning, or still we can use it for industrial operations or not. So, assessing the water quality is very important. Depending upon the water quality, we can use the water for various uses. Now, the water quality determination helps in identifying the present and the future problems of water pollution. So, we can, if we are assessing the water quality for longer duration, we can cross check that okay, this water which is getting generated or the water, whatever water is we are taking out from the ground, we are continuously seeing the change in the water quality characteristics. So, that means in future also the problem will be enhanced and we will have to solve the problem in detail. So, this helps in identifying the present and future problems of the water pollution. It also, the water quality determination helps in identifying the resources of water as per the various uses. So, we have to always look for the resources of water depending upon our uses. So, if our uses are different, then we have to see that how we can use the water. It also helps in developing plans and setting priorities of water quality management, so as to meet the future water requirements. So, if any city is there, its water requirement may be increasing because of the increase in population. So, we need to develop a plan for getting water for the enhanced population, increased population and for the city itself. So, this is there. Also, water quality determination helps in evaluating the effectiveness of the present management actions that have been taken earlier, and it helps in devising the future course of actions as well. So, overall the water quality determination is highly important. Now, what are the various principal constituents which may be present in the water or wastewater, and these constituents which may be important for us. So, for all those persons which are involved in treatment of water, these constituents we must always look for. So, first and foremost, suspended solid. So, if any suspended solid is present inside the water, it will cause sludge deposits, development of anaerobic conditions. If high amount of solids are present, they may be because of hardness and other things. So, the water cannot be used for industrial uses also. There are different possibilities depending upon the constituents present. Similarly, if biodegradable organics are present, that means the water contains organic matter which can be degraded. So, that means during degradation they will require oxygen. So, we will be having depletion of natural oxygen which will occur when the biodegradable organics are present inside the water, and it will cause septic conditions inside the water because oxygen will not be there. Also, the proteins, carbohydrate, fats, all these matter when present in water, they will be decomposed. So, we will be forming secondary products or ultimately CO2 and H2O, and depending upon whether oxygen is available or not available, we may form H2S also, ammonia also. So, we may have lot of order formation also happening depending whether aerobic conditions are prevailing or anaerobic conditions are prevailing. Now, all these biodegradable organics are measured in terms of biochemical oxygen demand and chemical oxygen demand. For biological wastewater treatment, this is one of the most important criteria. So, we will be learning this BOD and COD in detail in today's lecture or later on. Pathogens may also be present, and if they are present, they will cause diseases to various persons who are using these water. Similarly, nutrients, if they are present, nutrients like nitrogen and phosphorus. So, if they are present inside the water, they are the principal nutrients for growth. So, they may cause eutrophication of the lakes and ponds, and in the longer run it may not be helpful. So, we need to avoid release of nitrogen and phosphorus in the wastewater. Similarly, heavy metals, some other types of priority pollutants, refractory organics, inorganics may be present, and they may be getting added from different sources including industrial activities. So, heavy metals, they get added via wastewater generated from industrial activities. Many of these metals, heavy metals, are highly toxic at very small concentration also. So, they make the wastewater totally unusable for various any other uses if they are present. Similarly, priority pollutants may be present inside the water. These may be organic or inorganic compound having known or suspected carcinogenic, mutagenic, teratogenic nature. So, teratogenic nature, if they are present, they will be causing high toxicity and they need to be removed. Remember, similarly, we have refractory organics which are not biodegradable. So, organic compounds like surfactants, phenols and agricultural pesticide, insecticide, etc., they do not get easily biodegraded. So, that is why they are called refractory. So, they cannot be treated in the conventional method of wastewater treatment, and they have to be treated further via other means. Similarly, inorganics such as calcium, sodium, sulphate, they may get added from various sources including industrial sources, and they may cause the water unusable for various applications, and they have to be removed if the water is to be reused for any uses like in the industry or for cleaning also or for maybe bathing also. So, all these materials need to be removed. Remember, some of the materials like biodegradable inorganic or organic material, they can be removed via the biological treatment processes. Other have to be removed via physico-chemical treatment process. So, already I have delivered a course on physico-chemical treatment of water and wastewater, and where we have more given emphasis for physico-chemical treatment of water and wastewater. So, under physico-chemical treatment, heavy metals, priority pollutants, refractory organics, all these are getting removed via various processes. For biological treatment of water, biodegradable organics is important. If the biodegradable organics are present inside the water, including nutrients etc. are also, then we can go for biological treatment of water. Generally, the municipal wastewater which is generated in any other community, it has more presence of biodegradable organics and it can be treated via biological treatment methods. Whereas, the industrial wastewater which are generated in various chemical and process industries, they require physico-chemical treatment methods along with the biological treatment method for wholesome treatment of wastewater. So, depending upon the constituents which are present inside the water, the treatment methods may be different. The constituent present and their quantity help in understanding what type of treatment process we should adopt for treatment of that particular wastewater. Going further, the constituents which are present in the domestic and municipal wastewater, that we are going to study further, because they generally contain more biological organic materials and these can be treated via the biological means. So, in the domestic wastewater we have microorganisms which are present, it may be pathogenic bacteria, virus, worms, eggs, etc., and they may cause risk when we are bathing or eating, etc. So, this is one problem. Second is that they may contain lot of biodegradable organic material. So, they will deplete the oxygen inside the river, lake, reservoirs, etc., and the fish death may happen, the odorous condition may happen because anaerobic condition may prevail because of the oxygen depletion. Other organic materials which may be present inside the municipal or domestic wastewater include detergent, pesticides, fats, oil and grease, coloring matter, solvents, phenol, cyanide, depending upon that from where they are getting generated. So, suppose any city is having a car washery. So, from the car washery oil and grease will get generated. Similarly, some small industry may also be present inside a city premises also or just outside the city premises. So, municipal wastewater which is getting generated, it may get some amount of all these materials and we may get all these. So, other organic materials. So, they cause lot of toxic effect and aesthetic inconvenience, because the water will become colored or blackish in nature. So, it will not look good. Similarly, nutrients may be present like phosphorus, nitrogen, ammonium, etc., and eutrophication may happen. Metals, other inorganic materials may be present depending upon the other industries present in the vicinity or not. Similarly, thermal effects may be there if the hot water, the water is at higher temperature, in particular the water which is generated from thermal power plants, it is having temperature much higher than the usual temperature of the water. So, that means the hot water condition may be there, under that condition the flora and fauna may change. Odor and taste may also be different. So, hydrogen sulphide may be present depending upon the anaerobic condition or not. But first 4 conditions are always possible in any domestic wastewater treatment plant wastewater, and we have to treat further this domestic wastewater in the biological treatment process. So, biological treatment process generally will be designed to remove all these materials, but the other organic material they may get removed or not depending upon their presence and their quantity, how much quantity of these things are present inside the water. Now, the typical range of polluting parameters in the raw municipal wastewater is given here. So, we have different parameters which are listed here. We are going to further study these parameters. So, TSS is total suspended solid, okay. BOD is biochemical oxygen demand, COD is chemical oxygen demand, and this is total nitrogen, total phosphorus. So, for biological treatment all these parameters are very important. So, BOD 5 or BOD 3 may be there. Their ranges are given here, 100 to 350 milligram per liter for TSS, COD 250 to 1000 milligram per liter. Certainly, it may vary depending upon from where it is getting generated. So, all these constituents may be present inside the water. Now, we are going to learn how to determine all these parameters and what is the basic understanding of all these parameters before going further. So, now we are going to understand the water quality parameters that we have to determine. So, there are different types of water quality parameter, their classification is different, like physical water quality parameter, chemical water quality parameter, biological or biochemical and bacteriological. Remember that already I have given lot of lectures related to water quality parameter in another course on physico-chemical treatment of wastewater. So, there we have explained all these parameters in great detail in 7-8 lectures. So, we can always go and understand all these parameters in detail. Here we will be just relearning these parameters quickly, and I will be discussing in detail the biological and biochemical water quality parameters in detail, because these are of more use to us for biological treatment of wastewater. So, if you want to study all these parameters in great detail, please see the lectures on physico-chemical treatment of wastewater. Now, physical water quality parameters, what are the different physical water quality parameters that we need to determine? So, these include first and foremost the temperature. The physical water quality parameters are like those which can be sensed by our senses. So, temperature is one of the parameters. We need to determine the temperature of the water. The temperature of water is generally same as ambient temperature, but under certain conditions the water coming out from a like thermal power plant, it will be at higher temperature. So, we have to see that the thermal pollution should not happen. So, that is why we should report the temperature of the water at its source. Similarly, the temperature of water also affects the specific conductivity of the water. So, that means if the conductivity is if the temperature is changing for the same water, the specific conductivity will also change. So, specific conductivity is expressed as micromole per centimeter at 25 degree centigrade. The specific conductivity of water in micromole per centimeter at 25 degree centigrade is multiplied by a coefficient, generally it is 0.65, but it may vary from 0.5 to 0.85 around, to obtain the dissolved salt content in milligram per liter. So, remember the specific conductivity, there are different types of simple equipments which actually they measure the specific conductivity, but they multiply it by a coefficient and they directly give the value of dissolved salt content, which is called as TDS. So, we can always see that the TDS value, but actually it is those simple equipments actually measure the specific conductivity, and from that they report the TDS values. Then in the physical water quality parameter, color is also an important parameter, and color is also important for biological treatment of water. Also in particular, if the water is generated in industry like textile and we are performing some water biological treatment process. So, we have to measure the color removal efficiency etc. also. So, color measurement is very important and color removal efficiency measurement is foremost important for treatment process. Now, the color of water is usually due to presence of organic matter in the colloidal condition. So, all various types of organic matter get dissolved in the water and they impart color. Due to the presence of minerals, dissolved organic and inorganic impurities, they also impart color to any of the water. Now, the color is further classified as apparent color or true color. Apparent color is the color of the whole water sample and it consists of color from both dissolved and suspended components. So, that means if suppose we are taking out water from any source and so we will see some color. So, that will be apparent color. After some time it may be possible that the suspended components they get settled down and the water after some time its true color will come out, because all those suspended materials are getting removed and they are settling down to the bottom. So, we will be getting true color. So, true color is measured after filtering the water sample to remove all the suspended material. So, that will give the true color of the water. For water samples with yellow tinted color, there is a method which is used for reporting the color of the water. So, if any water which is yellow tinted, remember it is for yellow tinted color. So, the platinum cobalt scale is used and it is also called alpha Hazen scale. So, remember it was given by Hazen and it is used for reporting color of the water samples with yellow tinted color. So, this and the instrument is also available for this. Okay. Now, if we have to determine any other color, so it is very difficult to remove the color of the water in actual way. We generally use UV visible spectroscopy method, which actually uses ultraviolet or visible light. So, UV range extends from 100 to 400 nanometer and the visible range extends from 400 to 700 nanometer. So, this whole UV visible range from 100 to 700 nanometer is used to determine the absorbency of a substance or of a water sample. So, what we do is that we can take water and we determine the absorbance of the water at different lambda, and this lambda will vary from 100 to 700 nanometer. Now, this may change like this. Okay. So, what we report generally is the lambda at which maximum absorbance happens. So, this is called lambda max. This is not the maximum value of lambda, this is the value of lambda in the UV visible range at which maximum absorbance occur for that water. So, this is will be the tentatively the color of that water. So, the lambda value gives the idea that what is the tentative color of that water, and the same technique actually is used for determining the color removal efficiency by any treatment method. So, what we do is that we determine the lambda max of that water before treatment and we note down the what is the absorbance, suppose this is A1. After treatment again we will try to find out the absorbance of the water at that lambda itself, which is the lambda max. So, suppose the water after treatment comes out like this. So, we will be getting a second lambda which is A2. So, from A1 and A2 value we can determine the color removal efficiency of any wastewater treatment method. Going further, similar to color, there is another parameter which is called turbidity. So, turbidity actually measures the resistance of water to the passage of light through it. So, we have how much light is absorbed while the light is passing through the water sample, that is given by the turbidity. Now, this turbidity is measured in terms of unit which is called NTU. NTU means nephelometric turbidity unit, and the turbidity 1 NTU is the amount of the unit which is actually produced by 1 milligram of formugin polymer in 1 liter of distilled water. So, whatever if suppose the formugin is dissolved in 1 liter of distilled water and that sample is measured and that sample the resistance is measured by a nephelometer, then we can find out the 1 NTU. So, that will be given 1 NTU and all the turbidity for other water samples is measured using nephelometer. We always want the turbidity in terms of NTU to be minimum possible. For drinking water, Indian standard prescribes the water to have less than 5 NTU of turbidity, then only we can use the water for drinking purpose. Then there is another parameter which is called order. Now, there are order of a water sample is very difficult to measure. So, there is a one parameter which is called threshold order number TON. Now, TON is actually defined via this particular equation which is given here, A plus B divided by A. Here actually the A is the sample volume. So, we have a sample volume which is measured in ml, and what is done is that this sample volume is always diluted by a dilution water, okay, dilution water which is not having any order. So, this water is not having any order. Now, this sample volume is diluted with this dilution water to make the sample equivalent to 200 ml. So, this A plus B is always equal to 200. So, this is how we this TON is reported. Now, how to determine the TON? what is done is that the sample, water sample is taken. So, we have different types of water sample which are taken. So, it may be start from taking suppose 1 ml, 5 ml, then 10 ml, 20 ml, like this we can take larger amount of water sample, then this is the value A. Okay. Then we have the dilution water which is the value B, and this is taken. Now, this will be here, it will be taken as 199 ml. So, that A plus B is always equal to 200 ml. So, this should be there. So, here it will be 195 ml, here it will be 190 ml, and then similarly 180 ml, 150 ml. So, always they will be taken in such a manner the total A plus B value is 2 this. Now, what is done is that a few persons are like taken and they are requested to check whether under from which sample the some order is coming out. So, people will start from here. So, if suppose 10 people are there and 7 are telling that okay, from this A plus B sample, some order they are able to perceive. So, that means this is the T1, because majority of people are reporting the, certainly if they are getting order from this sample, they will always get order from other samples. So, we always report the minimum diluted water which is having some order. So, that means the TON of this particular water sample for which different samples were taken in different amounts. So, for this the TON will be 200 divided by 5, that means it will be 40 is the TON of this water sample. So, we studied this way, the TON is reported. We can find out other water quality parameters like solids also. So, we will be studying in detail the within the physical water quality parameter what are the different types of solids which are present and how they are reported. Further, we will be studying the chemical water quality parameters, biochemical water quality parameters in the next lecture and onwards. Thank you very much.